Day 4 is simplifying radicals. So let's take a look at these numbers squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So when we look at radicals, we have 3 pieces to a radical. We have what we call the radicand, which is underneath. We have the index, and we have the radical. So the radical is the check mark looking sign. The radicand is the number underneath the radical, and the index is the number outside or above your little check mark. So a square root has an index of 2. So the n, or the number that is in a square root, is a 2. So if we have the square root of 36, 6 times 6, or 6 squared, is equal to 36. So we would say that the square root of 36 is equal to 6. The square root of 64 is equal to 8, and that is because 8 times 8, 8 to the second power, is 64. The square root is always positive. So when we look at negative square root of 121, the negative, we're going to remain on the outside, and we ask ourselves, what number multiplied by itself is 121? And it's 11. What number multiplied by itself is 81? And it's 9. So plus or minus 9 is the square root of 81. So the first method that we're going to look at is the perfect square method. So we are going to find a factor of the radicand that is a perfect square. So I know that 90 is divisible by 9, which is a perfect square, and I can multiply it by 10. Rewrite the radicand as a product of these two numbers. So the square root of 9 we know is 3. Square root of 10 we can't simplify, so we leave it 3 root 10. If we need to repeat, because there's another perfect square that goes in underneath the radical, we could. So 48 I know is divisible by 4, which is a perfect square. The square root of 4, 12 is also divisible by 4, so we can rewrite that as a perfect root, square root of 4 times square root of 3, and then we can't simplify those radicals any further. We know the square root of 4 is 2, square root of 4 is 2, so when we multiply 2 times 2, our simplified radical is 4 root 3. So let's take a look at some additional examples. 72 is divisible by 9, which is a perfect square. 9 times 8 is 72. 8 is also divisible by a perfect square. 4 times 2 is 8. Square root of 9 is 3. Square root of 4 is 2. 3 times 2 is 6. Root 2. The plus or minus outside the square root of 20 remains where it is. 20 can be simplified by 4 times 5. 4 is a perfect square, so the square root of 4 is 2. Root 5. 81, square root of 81 is 9. Let's take a look at a few more examples. 60. I know 60 is divisible by 6 and 10, but neither one of those are perfect squares. So let's try 4 and 15. The square root of 4 is 2. There's no perfect squares that go into 15, so we're finished. 125 is divisible by the perfect square 25 times 5. Square root of 25 is 5, and we have root 5 left over. Negative 18, remember the negative is just going to stay out front of your radical. 18 is divisible by 9, which is a perfect square. Square root of 9 is 3. Radical 2 can't be simplified, and we are finished. You now can complete your practice worksheet.